Okay. So application for the OS, agriculture, chemical, so on. Advanced, of course, multi-element, right? Wait for a while. Right, the advantage of ICPOES is multi-element technique, of course. Multi-element meaning that we can detect various type of metals at one time, different with AAS and AES. Okay, for AAS, remember, and AES, we only can detect one time. So it also has fixed chemical interference, excellent linear dynamic range, up to 100 to 1000 ppm. Okay. Too excellent, 0.5 ppb, part per
Sir?
billion, very low detection limit, meaning, yes, yes.
We stop at the quiz, and then we need to start at the nebulizers before that, before this subtopic.
Oh, we stop at
Quiz.
sorry for that. Okay, sorry. All right. Oh, sorry. Okay. So similar with the AAS and AES in the ICPOES. Okay, we have nebulizer. What is the function of nebulizer? To atomize the sample, to spray it, to let it pass to the plasma. Okay, so we have several type of nebulizer: concentric nebulizer, microconcentric nebulizer, cross-flow nebulizer, Babington nebulizer, V-groove nebulizer, and cone spray nebulizer. But the function is all similar, right? Is to transform, okay, to convert a liquid sample in the container, then pump into the nebulizer and introduce it to plasma. What happens if we don't transform all the liquid sample into aerosol type? Okay, into aerosol type of very small droplets of the liquid. If we don't transform, so the sample will not completely burn in the plasma. Maybe some of the sample will drop, okay, somewhere, because we need it transform into a nebulizer form, into a aerosol form, so that the purpose of the end of all analytical instrument is to as much as we can the analyte in the sample. We do not want the sample to drop somewhere or waste somewhere. Okay, we need all the analytes in the sample being analyzed. So we transform the liquid form of the sample into aerosol form so that it can be burned into the plasma, right, and can be detected by the detector. This is how the nebulizer looks like. Okay, it's like you spray the water in your house. You have what Febreze or anything else in your house that need to be sprayed. Okay, or you have pesticide spray in your house to mosquito spray. Okay, in your house. Yeah, that is how the nebulizer concept looks like. Okay, to aerosol. Um, spray chamber in the instrument is to remove the large droplets from the aerosol. In the aerosol, there are some large droplets. We don't want that large droplets. We need to make sure all the droplets are small, okay, and smooth out paths that occur during all droplets with diameters of about 10 micrometer or smaller to pass to the plasma. 95 to 99% of the sample is drained into a waste container. Okay, made from corrosion resistant material. So after the sample being transformed into the plasma, okay, the waste will be into a waste container chamber. We have a conical type, a Scott type. This is just for information. And then we have a radio frequency generator in the instrument. Provide for the generation of plasma. Okay, remember we need a plasma there. So it is the power for the generation of plasma power provider, and sustain the plasma discharge. Okay, 700 to 1,500 watts. And ICPOES operate at the frequency of 27.12 and 40.68 megahertz. Okay. Right. We have the detector. In every analytical instrument, we have the detector. So remember, you have seen the word photo multiplier detector. Okay. Before this, okay, you have seen this in the UV instrument. Okay. The solid state detector have the photodiode array, charge injection device, and charge coupled device, and segmented array charge coupled device, SCD. So what is the purpose of the photo multiplier is to multiply the response in terms of what? Of the energy. Okay. What is the purpose of multiply? Okay, if we have a small response, we need to multiply the response easily and transform into the concentration information by the detector. Come to the application. So I've told you a lot of application for ICPOES. Okay, advanced. Okay, also have spectral interference control through instrument. We can control the interference spectral in the instrument, okay, so that we can differentiate between the interference and the real response. This sample can be analyzed in seconds per minute, very fast. Okay, in ICPOES we can detect the analyte in the sample very fast. Okay, so now we have come to the next instrument, which is the inductively coupled plasma mass spectrometry, ICPMS. So now I would like to ask of all of you, what is the atomizer part? What is the atomizer part in the instrument?
MS.
MS is the detector. What is the atomizer part? ICP. Similar with the ICPOES. Okay, atomizer is the first word. Okay, and mass spectrometry is detector. Okay, similar with ICPOES, ICPMS, the atomizer, but the detector is different. Mass spectrometer, right? So we have plasma for atomization. Okay, similar. And we have MS as the detector. And then we can know the structure of the sample. This is how the instrument looks like. But this is the instrument. We have the latest version, which is quite smaller than this in our lab. Okay, as I told you, when you can can be UTM, I will bring all of you to make a visit to all of. So this is the metals in terms of mass. Okay, so how the ICPMS detect minerals, the metals, is in terms of mass. Technique to determine element using mass spectrometry from ions by an ICP. Okay, the ICP will burn the up to the ion state. Okay, and then the mass spectrometry, the mass of the elements. So mass spectrometry is a measurement of the mass of individual atoms of a material. Instrumentation, we have a similar with ICPOES. We have ionization source, similar. We have ion extract system, interface and vacuum. Focusing system, lens assembly. We have mass filter, okay, and ion detection system, the detector, and this is the this is part, detector, and atomizer. Okay, schematic diagram. You can see where is our sample here at the spray chamber, right? First one. Okay, so RF provide power to provide plasma. So our sample is being sprayed using spray chamber into aerosol droplets and introduced inside the plasma, and the come to the ion lens, okay, and into the mass filter quadrupole. This is for detector, okay, and we electron multiplier, okay. Part in the ICPMS is very expensive. The MS instrument that have MS part, mass spectrometry, the mass spectrometry is very expensive part, okay, because it can differentiate the elements using their mass, okay. Different with ICPOES, the detection is using optical emission, but this is in this instrument, the detection is using mass, okay. This is the interface. And extraction system, okay. We have, of course, we have a couple hash of plasma, okay, in very high temperature. And then we have interface to ions from the ICP to the spectrometer, where the mass separation will be done. And the ions from the ICP travel through the sample cone and then the skimmer cone, okay, due to the interference, due to the difference in pressure, right? This is how the plasma being produced and will get into the plasma Okay, and the ions will from the ICP to the spectrometer. Okay, it must go through the interface part. Okay, so we have a sampler cone in the ICPMS, cone, and photon stop and ion lens assembly. The ions are sampled through a 1 millimeter orifice into 1 to 3 Torr pressure region. The sample material are representative of plasma central channel. Argon atoms are removed by vacuum. In the schema cone, the ion beam is further sampled through a second orifice, okay, 0.9 millimeter to into 10 to the power of -5 Torr region, and then the photon stop located on axis to block the photons, and ion lens assembly used to focus the ion beam. This is how the diagram of the photon stop and ion lens. Ion beam focusing system. Okay, we have a lens assembly. Okay, focus ions extracted by the interface and send them into the quadrupole. Right, this is the schema. Okay, this is cylinder lens and aperture. Using the electric field from a specially shaped metal piece, push into the quadrupole. Okay. It separates one type of element from another. The electromagnetic field of the quadrupole rods allow only one mass to make it through at a time. Okay. So many masses enter the quadrupole, but only one make it out. Okay. Number of ions leaving the mass filter and ions leaving the quadrupole collide with the detector, producing a cascade of electrons which can be measured by the signal electronics. Okay, and then the response of every single element. Detector, mass spectrometry. The detector is no longer using the optical emission technique, right? It's using the mass of every single ion. Okay, so in this part, single atoms of elements are being counted. Okay, how it's being counted? The ions leave the quadrupole. Remember, the mass enter only one, make it out. Okay, it will filter all the the mass inside the sample. Okay, the mass of the ion inside the sample being filtered here. Okay, that pass through the quadrupole are being identified. Okay, so the dynode detector will count every single ion that leaving the quadrupole, leaving the mass filter. Okay, and then ion leaving the quadrupole detector and producing a cascade of electrons which can be measured by the signal electronics. So remember, every single element have the unique. Okay, okay. Remember, every single element have the unique mass. Okay, this is how the dynode detector detect. by the charge of the ion, okay, different between one and another. In ion, we have a charge, right, for positive and negative ion, and the energy of every single ion in terms of the charge is different from one another. So here, the charge, okay, when the ion leave in the corona ball and collide with the detector, producing a cascade of electrons, right? Charge of the single ion, it will be measured by the signal electronic. And we have a selective, okay? We have a different mass for every elements that being detected, okay? For copper, we have a two type of copper, okay? Let us for a single element, we have an elements, you know, what we call that? You have learned before this? Isotope. Remember what is isotope? Define the isotope for me.
Same number of proton but different number of neutrons.
Same number of
Protons but different number in neutrons. Neutrons.
Okay. Else? Is it correct? You agree with who's speaking just now?
Anis.
Anis, okay. So everyone agree with Anis? Definition of isotope? All right. For every single element, we have several type of isotopes. So in ICPMS, we can differentiate, okay, isotope of the elements, okay, because we are now dealing with the charge, right? In terms of the mass, okay, we differentiate every isotope of the element. Of the ICPMS, similar with ICPOES and other instruments for environmental, clinical, okay, for blood, urine, serum, okay, isotope tracer studies, okay, petrochemicals, okay, geochemical, metallurgical. Now we compare ICPMS and ICPOES. For ICPMS, okay, can be detected are most metals and non-metals. Okay, non-metals meaning that we have antimony, okay, arsenic, right? That is not you know the metals that are of non-metals. Okay, it's part per
Trillion.
Trillion. Good. Meaning that the detection limit is very low. If you have the detection limit of the instrument that is very low, so it is good or not?
Good.
Yes.
Yeah, good, because very small concentration we can detect by this instrument. Advantages: rapid, fast, okay, sensitive, multi-element, wide dynamic range, okay, good control of interference, and disadvantage is limited total dissolve solid tolerance. And then for ICPOES, most metal and some non-metals. Okay, in terms of price, of course, ICPMS is much higher, more expensive than ICPOES. Limit, okay, to ppm, okay, meaning that detection limit of ICPMS, rapid multi-element analysis, of course, advantage of ICP. If you saw ICP, meaning that we can detect multi-element. With AAS, AES, single element. Okay. Appearance and relatively poor sensitivity, right? Instrument, AAS, a flame, graphite furnace, okay, and then ICP we have several types. This is the comparison of the detection limit. Okay, now we differentiate between AAS, AES, and mass spectrometry. Okay, what is the difference? How do we compare AAS and AES? What is the difference between AAS and AES?
The light source.
Yes, we have the light source here, okay, because we measure how much of the analyte absorbed from the light source. Detector will detect the missing light, the missing energy in the being absorbed by the analyte. So that is represented by the how much of the analyte inside the sample. AES, we don't have light source because the sample being burned in the flame, the electron in the atom will be excited from ground state to excited state and come back to the ground state, okay, and when the electron come back to the ground state from excited state, there will be some emission of energy for every element, and then will detect by the detector. But what is the difference between AS and AES in terms of when we have this measurement of analyte inside the AS is by the absorption of the energy, right? This one is by the emission of the energy. So the difference is the detection limit, right? This one is PPP. Okay, larger. So which one is more sensitive between AS and AES?
AAS.
Because we have the lower detection limit. Good. Okay. Now, what is the difference of this instrument, AS, AES, and mass spectrometry instrument, ICPMS? If we have we're not using flame, furnace. We have a phrase here, right? We have a plasma of very high of atomizer, right? Mass spectrometer, not using the kind of the light detector, right? Emission of energy or absorption of energy in terms of light, but it detects the mass of every single ions, right? Burn the sample completely to become ion state and then count here in the mass spectrometer, right? This is very similar. So any question, guys? I want to congratulate to, we have 2 winners from this class, right? In my last OGC, Online Global Classroom, right? How many winners we have in this class? Am I correct?
Yes.
And then we have Nana, I think. Right? No. Who the winner? Who are the winner from this class? Let me read. No, right?
I think no.
Who is
Nana
Nana?
is not from.
What is her full name?
Tasha, Dr. Tasha.
Oh, okay, but I think Nana from this class.
Nama dia Natasha.
Yes. Tapi nama tu dia letak ya Natasha lah kan? Natasha, right? Natasha from this class. Irfan, Natasha, Faraliana in class or not?
No.
What is the full name? Oh, Faraliana is not from this class. Okay. So the first place, Ira is my student in the chemistry department. So she's in 4th year in my class. She learned voltammetry, of course. Okay, in my subject electroanalytical, so of course, she will be the winner, right? All right, so congratulations. I will, those who win the quiz, I will ship the present to you, the prize. Okay. So how about the quiz? All of you have submitted the quiz. All of you have submitted the quiz in the e-learning, right? Right. So who want to scan the attendance? Anybody?